Now, student, this is a live class for 12th class syllabus, right? If you want to watch 11th class syllabus, I started oscillation. You have to join. You can join by tomorrow, 8 o'clock every day, right? So in this class, student, I can see last live session means yesterday. I just beta started simple. What is the definition of electric field? And next part, student, myself already I can say completed beta. That is, I can say basically properties of electric field lines. Uh, I can say I completed the properties of electric field lines. There are three properties of electric field lines only, right? So remaining, beta, there are more than I can say two or three. So beta, I wanted to just complete with you, right? So in this class, my dear, I'm going to just beta start from what I can say properties of electric field lines. What, my dear? This is properties of electric field lines, right, beta? Okay. So here, student, just I'll recapitulate here all the I can say in sequence, my dear. So, beta, this is the first one. Already I said, but still I'm repeating it so that I can say entire concept together. You can revise, my dear. Now, students, this is what properties of electric field lines. No, beta, positive charge, beta, you can treat as a source, my dear. So this is you can say source of light. Positive charge beta, you can treat as a source of light beta. What's the meaning, bacha? Electric lines always originate from what? Electric lines always originating from positive charge or my dear infinity and terminates on negative charge or beta g infinity. So this is student which I said about this is the properties of electric lines. Electric lines, my dear, always beta g originate from positive charge and beta g terminates on negative charge, or you can say beta this is what infinity. This is the property one, bacha. Now, what's the property two, bacha? You can say, my dear, electric field lines never intersect each other. What, my dear? Electric field lines never intersect each other because at a you can say at an intersection point, there are two possible directions, which is practically not possible. What, my dear? Which is practically not possible. Okay. Now, beta, I can say what's the beta next here? Beta properties number three. What, my dear? This is what properties number three. Beta property number three, you can say, bacha, for this condition. What about properties number three, bacha? Yes, beta electric field lines gives us net electric field. Let us suppose, students, you can take this is what charge Q1, this is what charge Q2. If you are looking to find what is the net electric field at point P due to these two charges. So you can say, bacha, electric field due to point charge, beta, beta in this direction, electric field beta due to this charge beta you can see in this direction, right beta? So this is what, my dear, you can say this is what net electric field. This is what, my dear, you can see this is what net electric field due to these two charges. So you can beta remember electric field lines gives us what net electric field lines beta. Okay, beta the properties number four. What is student properties number four? Beta electric field lines. Beta if electric field density is more, then beta the electric field intensity is more or vice versa. What, my dear? Electric field density is more, then student electric field density is vice versa. Student, if electric field density is more, let us suppose you can take beta. This is point A. This is what, my dear? This is, you can say, point B. So, beta, what is the meaning here? Beta, I can say property number four. If electric field density is more, then beta, Electric field density is more, mean electric field intensity is more, or vice versa. Electric field lines, beta what you can say, electric field density is more, then beta electric field intensity is more, or vice versa. Beta, me remember, bacha, electric field density is more, then student, electric field density is more, or vice versa. Okay, bacha, so you can write my dear here. This is what electric field at point A is what, my dear? Greater than bacha, electric field at point B. Beta, what you can say? Electric field at point B. Okay. Now, bacha, I can say, beta, have a look at, I can say properties number 4. What, my dear? Properties number 4. Okay. So, beta, properties number 4, yeah. Or 5, bacha, I can say 5 na, beta? 1, 2, 3, 4. Yes, beta, 5. So this is here I can say properties number 5. Beta, what is property number 5 here? Electric field lines never form a closed loop. What make, my dear? Electric field lines is good. Let us suppose you can say this is a loop. This is a loop, right, beta? So what's the beta? I can say beta maximum time CBSE also asked, my dear. Beta G, CBSE also asked, my dear, right? Electric field lines never form a closed loop because electrostatics was conservative force, right? And work done by conservative force, what? Not equal to zero, bacha. What I said, bacha. Electric field lines, my dear, never exist in a closed loop because it belongs to what? Conservative force, bacha. Right? Then, bacha, I can say, beta, for this question, you can also remember, my dear, that is what, bacha. No, beta, for work done by conservative force, this is what, my dear? This is what? Work done by conservative force, beta, is equals to zero here. Beta, work done by conservative force is equals to bacha ji, zero only, right? Beta, this is students, 12th class. Beta, I started Electro 1. Beta, under Electro 1 student, now, beta, I already finished, beta, I can say Coulomb's law in a beta medium and Coulomb's law in a beta air. Now, beta, this is when in last class, beta, yesterday I took only 25 minutes class. I explained what is the electric field. So, in fact, beta, already yesterday I stated, I explained few properties of electric field lines. So, this is beta discussing over here in the live electrostatics beta chapters beta. I can say that is what electrostatics and syllabus and beta particular name beta I can say that is electric field, which is beta going on. Now, bacha, so what I said, electric field lines never exist in a closed loop, bacha. So you can see work done due to what? Conservative force, because electrostatics force, beta, what? Electric field, bacha. Electric field, beta. I said, my dear. Beta. So work done due to, I hope all of you remember from beta what you can say 11th class concept, bacha. Work done due to conservative force, what? Always equals to zero, beta G. Okay, so let us suppose you can take as an example. R is what, my dear? R is what? Radius. R is what? Do you also do J label? Yes, beta. This is a class, beta. Just see, beta, thumbnail. Beta, once see, beta, thumbnail, there is mention, beta. JEE advanced preparation begins. Right, beta. I'll discuss everything, beta, slowly. Yaar. It's a live stream, beta. So I'm, beta, considering pan India student, beta. I can see zero to hero, beta. Just wait, beta. You will get all level of questions here. Right? Just give me, beta, seconds, beta. Let me complete my idea. This is what properties number 5 beta. So what I said, electrostatics was conservative in nature, right, beta? Okay, so work done due to conservative force is equals to zero. Let's beta try to understand here. Let us suppose we can say there is a charge particle, and charge particle beta you can take in motion towards right, left directions, right? So students here, let us suppose uh, uh, we wish to find work done. So what's work done with the party? You can say here. So this is nothing but force into you can say with party distance. You can also say displacement. Both are correct only with So you can write, my dear, work done. Beta, what is force here? F is equals to QE. What's the distance here? This is you can say 2 pi r, which is not equal to 0. So due to this, bacha, what you can say, electric lines never exist in a closed loop. Okay, but I have looked at one advanced questions, my dear, right? Because you demanded here. I'm in 12th, but don't study electricity properly. Can I study from now? Yes, 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 my dear. Beta, physics point as a platform, my dear. Literally, you will learn beta from zero to hero, right? So I explain beta property because you know, beta, multiple times J mains or beta, you can say in AI triple E previously, beta, they were conducting before I can say 2012. Orbiter CBSE also ask my dear multiple time, right, my dear? So stay in the meeting, beta. Okay. So beta, in the last class here, I gave one approach for the question, beta. So just beta, again here, I'm looking to do same questions only. Yes. So what question, beta? It's beta question, beta, which I'm going to do, beta. That is for advanced. Means beta, they can also ask. But usually, beta, you demanded for advance here. So I remembered one questions, right, beta? I'm going to beta discuss. That is beta, those questions here. So you can say beta questions is what? You can take beta a ring, student, a ring of, you can take beta a ring of radius beta, you can take this is a point 1 meter is beta made out of is made out of beta thin ring. What, my dear? Made out of beta, you can see what? Thin metallic wires. Thin students, this is metallic wires. Thin metallic wires of area of cross section of students, area of cross section 10 to the power minus 6 meter square. Full stop. The ring, the ring has a uniform, the ring has student uniform charge. Ring has a uniform charge of beta z pi coulomb. What was that? Pi coulomb. Find find the change in radius beta. Find the change in बच्चा जी radius. Find the change in radius of ring. What beta? Change in radius. Change in radius of ring when when a charge a charge of 10 to the power minus 6 coulomb is beta g placed at the center of ring. Beta full stop. Beta you can take a few data. Young's models beta they mentioned here. Beta how much? You can take beta something here. It's very beta 2 into beta 10 to the power 11. Beta God bless you for your reaction. 2 into 10 to the power 11 Newton per meter square. Beta this is a question. You know beta in live class I can see in physical classroom I never wrote questions never stated. Simply beta straightforward. I use beta diagram and just go through these. But now it's a live session, beta, live streaming. So I have to care each and every one, beta. Because of this year, I wrote the question. Again, I'll read once. A ring of radius, beta, just write. No, beta, because are always solving any question. It's the best step. So, step beta, just you can write first. What is, my dear, given data? So, you can see what's the radius of ring. That is what, my dear? This is point 0.1 meter. Okay, student also mention your area of cross section. that is 10 to the power minus 6 meter square. Beta, the ring has a uniform charge of pi coulomb. Beta, you can see on periphery. Beta, this is, beta, you can see charge. You can write, my dear, charge on periphery. Charge on beta periphery of ring. Charge on beta periphery of ring. Beta, how much? This is pi coulomb. Okay, find the change in radius of ring when a charge placed at center. Okay, beta, I can say next beta G. Of next location of charge. Charge at beta what you can say? Next location of charge at center. That is what, my dear? 10 to the power minus 6 coulomb. So we have to find radius. I guess what we have to find? Change in radius, not radius, my dear. We have to find bacha party change in radius. It's not tough here, it's a good questions. Now, beta, this is I wrote beta, it's step one bacha party, right? Have a look, beta, ji, it's literally good questions here. Yes, beta, it's literally good question, beta. You can beta anywhere, you can watch beta detailed solution, beta, ji, right? So have a look, my dear. In step two, students, this question explanation here. Already I said, beta, if you have a ring, beta, you can take beta. Charge already mentions on the periphery of ring, beta. This is what 5 coulomb. Beta, charge at the center, beta. What mention? 10 to the power minus what charge is 6 coulomb. Right. Beta, you can take care. I have taken small r bacha. You can also take care. R is a radius of frame. Beta, in last class, yeah, already I proved this result, bacha. But here now I'm going to use beta directly, my dear. That is what student tension in a rotating ring or tension in a ring, bacha ji. Simply you can write beta ji as a short trick here. As a short trick beta. As a short trick beta, always write here tension in a ring vector. This is what Fc upon beta g 2 pi. It's a highly required beta g. Just beta, what is the value of FCR? It's nothing but it's a what? Like charges beta. So repel each other, my dear. So simply you can write beta. FC is nothing but K Q1 Q2 by R square. That's what beta. F is what? K Q1 Q2 by R square, my dear. Okay. Now beta ji, here beta, this value beta, FC beta I'll use here to find the value of tension, my dear. Which topic questions? Beta, these questions beta you can say from basically beta Coulomb's law. Yes, beta. This topic beta I can say questions, my dear. This topic beta questions from beta. This is Coulomb's law. Yes, beta. Yes, beta. It's questions beta I can say from Coulomb's law, beta. Oh, yes, beta ji. Now, beta, tension here. I wanted to find bacha. So, FC bacha, I can feed over there. K, Q1. Beta, if you wanted to the entire solution bacha party, then you can go bacha and watch beta. I can say first day lecture of electrostatics, my dear. There is beta mention detailed solution how I wrote FC upon 2 pi beta. K Q1 Q2 by beta what you can say, my dear, 2 pi r square. This is the tensor beta, which you can find from here. Fc is Fc beta centrifugal force. My dear, this is a like charges beta. Just you can take consideration here. You can understand beta. Not Fc is not a centripetal. Beta Fc not centripetal beta. Fc is beta centrifugal bacha party. Right? So this is beta. At center charge beta. I'm just considering Q1 bacha. Another charge beta, let us suppose on periphery here. This is what? Suppression orbital. Let us suppose this is Q. So what you can say, my dear? So this is what like charges repel each other, bacha. Like charges what? Repel each other, bacha. Right? So, bacha, this is the tension here. So, beta, we used to find tension, beta. So, beta, I'll use my dear calculations further over here in step third, beta, ji, right? This is what step third beta dedicated calculation of tensions, my dear. So T is what beta? This is you can say K is what 9 into 10 to the power 9. 9 into 10 to the power 9 बच्चा party. Q1 Q2 beta. What's the Q1 बच्चा जी? What's the Q1 बच्चा? You can take your pi coulomb. This is what pi beta. Q2 beta, this is what? 10 to the power minus 6. K Q1 Q2 beta. This is what you can say, bacha? This is 2 pi. And R beta, you can say this is what? 0.1 beta the whole square. Simple, yeah. Okay. You can see, my dear. Sir, this pi finished. This pi finished. Beta, you can say this is what? 10 to the power plus 9 beta plus minus 6 beta. You can write t is what? 10 to the power 3 into beta 9 upon 2 into beta. This is 0.01. 0.01 bacha. Beta, this decimal beta, this replace bacha part in 2 times. Now beta, this is what 450. So you can get beta, this is 450 into 10 to the power 3 Newton. Tension bacha, you will get here. This is what 450 bacha party. Right. Okay. So bacha, in fact here, what is charge mentioned? Okay, I have taken minus correct bacha party. So beta, this is what you can see 450 beta. Tension you got. Okay, now beta further here, we wish to find what? Radius. So beta in step 4, my dear. Step 4 beta. Now beta, I'm going to use here concept of what? Now beta, I'm going to use beta what I can say concept of mechanics of solid. So what is the formula beta for mechanics of solid here? Young's modulus. Young's modulus, you can write, my dear. This is stress upon strain, bacha ji. Okay, fine. Students, you can write here. Stress is what? I hope all of you remember. Otherwise, I'm repeating, bacha. Stress is nothing but you can say force per unit area. Strain beta, you can say here. This is what? Change in radius. Upon beta, you can take radius, my dear. You can write beta as the same thing here, which I wrote here. So stress, you can write beta F upon A. This is what delta R upon R. Simple, bacha. We used to find delta R, bacha. Change in radius, bacha. So delta R beta, what you can say? F into R upon A into Y, bacha. So delta R finally you got, bacha. F is what? How much? This is nothing but beta. F is nothing beta. It's basically tension, which is what 450 10 to the power 3 Newton, bacha. Just keep it in mind, my dear. Okay. Now, bacha, you can say, yes, Krishna, here everything evaluate beta, literally curate material for JEE means in advance and little so here. I'll increase my level of like say beta numerical little bacha. Not I can say at random here I'll do anything bacha. No. With this point beta you will get everything Krishna. Okay, so beta f beta what you can say this is 450 into 10 to the power 3 beta. R beta how much? 0.1 here. So student this is 0.1 bacha ji. Okay. A beta how much? 10 to the power beta where is area bacha? S. 10 to the power beta ji minus 6. This is A bacha. Young's modulus bacha. Young's modulus beta you can say 2 into 10 to the power 11. Right. This is 0.1 beta ji. Keep in your mind here. Okay. Beta further we have to solve. Beta this will goes up bacha. So you can say delta R bacha ji. 450 into beta 10 to the power minus 8 into beta the 0.1 beta upon bacha the 2 beta you can say this will goes up bacha so you can say 10 to the power 6 my dear so you can say bacha this will comes down bacha one decimal so we can write beta further 450 my dear 450 upon beta the 20 into beta 10 to the power minus 8 plus beta this 6. Beta this decimal you can say cancel bacha. 2 beta what you can say this is 22.5 into beta 10 to the power minus 2. Into beta what you can say 10 to the power minus 2. Okay. So beta just further you can solve bacha party. Right. Beta how much? Beta either you can say beta answer in terms of meter bacha or beta do one thing here. Beta just multiply by here 10 bacha and divide by 10. Beta multiply by 10 bacha 22.5 into 10 bacha and divide by 10 into 10 to the power minus 2 beta meter only. You can see bacha this is what 225 beta goes up here. So finally you can write bacha this is what 225 my dear mm. 225 bacha. So this is the answer student. So this is the answer for this question. Sir, I'll join you tomorrow. Okay, my dear. Okay, my dear. Okay. Now, bacha. Beta, next questions here. So, beta, just now, beta, you can take one snapshot. Yes, beta, for entire solutions together only, my dear. It's literally good questions here. Yes, beta, because in mechanics, beta, there is application of beta, I can say in electrostatics, yeah, mechanics of solid beta. Due to this, I'm telling this is a good questions, my dear. Right, beta. Yes, beta. So, beta, just, beta, I'm going to just turn the page. Beta, you have to take snapshot, my dear. Okay, fine. Bacha ji, have a look, beta. I can say next question, beta. Just, beta, just solve beta one questions. Now, beta onwards, I'll do your electric field, my dear. I'll do, my dear. This is what electric field only, right? So, beta, here I'll give the beta. I'll not derive any result. I'll give the formula bit, and I'll try to do maximum questions, bacha. Right? Okay, my dear. So this is student. First, beta, just be remember everyone. Electric field. This is what student. This is electric field on the axial point of rod. What beta? On the axial point of rod. Beta, I'll do this derivation because beta, this derivation I can apply anywhere to solve a numerical easily, my dear. Right, beta? Okay. Students, here I'm considering you can say uniformly charged rod beta. Here, students, I'm considering you can take there is charge. Student, this is lambda coulomb per meter, which is uniform student. You can take beta L is what length of the rod. Now, beta, you can see this is the point P where we wish to find electric field beta. You can see this is point P is a distance from rod. Beta a distance from rod. Okay, bacha. Then beta, what I can say, student. No, what is the I can say beta beginning step for this question? What is the student beginning step for this question? Yeah, it's very simple. Yeah, anywhere if you're beta, I can say getting lambda. I can say in entire mechanics. So beta, it's a very real approach and it's a very easy approach, my dear. What you can apply beta? You have to move x. Student, you have to move x. You have to move student x and take element dx. Student, if you have a rod, so you can apply with this approach. You have to move x and take element dx, bacha ji. Okay, so now you can say this is what elemental mass, or here you can say beta this is what elemental charge. This is beta elemental charge. So this is what you can see, bacha. It's dq. It's dq, bacha. So dq is nothing beta. What you can say, this is lambda into dx. Lambda into dx. How bacha? Just I'll write once here. I'll write once beta. For lambda bacha, lambda is what beta? Lambda beta, you can say this is students linear beta. This is linear charge density. What bacha? Linear charge density bacha. Okay, so lambda is what beta I can say. This is basically bacha. You can write, my dear, charge per unit length. Yeah, we wish to find charge. So you can write, my dear, charge is equals to lambda into length. So beta charge is nothing here. Beta no, we wish to find charge for elemental, my dear. So you can write this is what dq. dq is equals to beta lambda into dx. dq is what bacha? Already I wrote bacha. dq is lambda into dx. Beta, we wish to find at point P electric field due to entire rod. Not beta, I can say, Namaste, my dear. How are you? How are you, my dear? Okay. So beta, here beta, I'm going to apply beta what? Electric field formula beta. You can take, my dear. This is step one beta. This is step two. This is what, my dear, is step two beta. Very good. I'm very happy to see bacha in live stream bacha. Okay, bacha here. Just beta, we concentrate. Beta, now I'm going to use bacha. This is formula. Electric field. What is student? Electric field. Beta is due to point charge. I gave beta this formula here in study class. Electric field due to students. You can say point charge. It's nothing but beta. You can see this is what? dE. So what is formula which is electric field into point charge? K Q by R square which is. So you can see this is K dQ by what? R square. R is what beta? Distance from beta, you can see point P to element vector G. So this is nothing but beta. You can say X square. dQ beta is already be found. So you can write vector. This is dE vector K into beta lambda into what beta dx upon x square. Student, this is expression only for I can say element. Only for what, my dear? Element only. But we wish to find electric field at point P due to entire rod beta. So student, in step 3, I'll use, my dear, that is what? Tools of mathematics, which is known as beta. You can see if you have a many small pieces you want to add all beta. So for that condition, students, you have to use, my dear, that is what? Concept of integration. What, my dear? Concept of integration beta. So this is, students, I can say step 3. This is what, my dear? Step 3. Yeah. So yes, beta. So beta, I'll just integrate beta. D already I calculated previously, my dear. So this is just integrate beta. K lambda dx upon x square. So student, you can just keep it out here. Constant terms. K lambda beta. This is dx upon x square. Students, you know what's the limit you can apply? It's beta literally a very very useful, my dear. Limit beta, I can say this is the lower limit beta. You can say this is upper lower limit. This is what? Upper limit. Beta, what is initial point, bacha? This is what? You can say A. Beta rod initial point beta from B is what? A. Up to what, bacha ji? A plus L. Beta initial point A, bacha, which is equals to lower limit. Beta upper limit, what, my dear? A plus L, bacha. So you can write here, this is A and this is what, my dear? A plus L. Yesterday I gave you, student, what is the integration of? You can use beta further as a result here. Dx upon x square minus 1 by x. What, my dear? Minus 1 by x beta. Integration of dx upon x square beta minus 1 by x. Beta, just integrate here. So what will get? This is electrical, my dear. This is k lambda beta. This is dx upon x square beta. What you can write? Already I wrote, my dear, here. This is nothing but 1 upon x. This is A beta. You can say this is A plus L. This is what, my dear? You can say A plus L. Beta minus, I'm keeping beta out. So A beta minus K lambda. Upper limit beta. 1 upon A plus L minus beta. You can say lower limit. Beta minus again beta. I'm keeping beta inside. So this is beta the K lambda beta 1 upon A minus beta 1 upon A plus L. So literally, Vichaji, this is what I can say. Very, very, I can say beta sometime beta, if you remember this result in the paper hall, will help you all out, Vicha. If you want, beta, this entire derivation of this formula, beta, you can, beta, just watch channel video at physics point. Beta, I'll upload as usual free video beta on YouTube. Anytime, anywhere, my dear, you can watch. Okay, beta. This is beta. I can see first questions. What electric field on the axial point of rod? Yes, my dear. Beta, have a beta. I can say next questions. So, what dear? Next question, sir. Electric field. What, my dear? Electric field at an equilateral triangle. What, my dear? Next question, bacha. Equilateral triangle, beta, or you can say electric field at an what? Equatorial point, or beta, you can say perpendicular point of the rod. This is beta. You can say this is electric uh, field at an equatorial point of rod. Student, electric field at an equatorial point. EQ. Yes, beta. Equatorial point of rod, beta. This is what, my dear, electric field at an what? Equatorial point of rod. Okay. Fine. So students, I can say beta for this class. I'll beta just will go through here. One, just I'll beta I'll write what's the expression and I'll give the formula beta, right? Here, bacha, I'll not give like entire derivation, bacha. I did it previously because beta ji, there is beta something here which you can keep in your mind, right, bacha? Okay. So beta, you can take my dear. This is what uh, rod. Students, you can take rod is uniformly charged beta lambda coulomb per meter. Students, you can take my dear L is what beta is the length of rod. L is what, my dear? Length of rod. Okay, beta. Here is student. We wish to find electric field at an equatorial point. Beta, you can take beta. It's the origin point. And beta, we wish to find electric field at here only. Electric field here only, bacha. You can take here at any random point, bacha. This is what R. This is what R. Beta, approach remains same, beta. See here also. Approach beta remains same here also, bacha. You have to beta. What I said, this is you can take beta origin point 0, comma 0. So you can say this is the minus L by 2. This is what plus L by 2 beta. Here beta approach remains same, beta. This I'm telling beta approach only. I'll not beta solve further. You have to move x beta and take element dx. Beta, you have to move x, my dear, and take element dx, right? So beta, due to this element, bacha, you can say this is what direction of beta electric field, which is nothing but you can see this is what, my dear, d. This is what, my dear, d only. Now, beta, let us suppose I'm calling, beta, I can take for consideration, beta. This angle I'm calling beta the theta. So you can see, sir, this angle also remains theta. This angle remains theta, beta. No, beta, I see it in the beta. I can see in a study lecture. Electric field is what belongs to quantity vector. So I can take beta dE cos theta, beta. This is d cos beta. See what you can see d sin theta. Just keep in your mind. Let us suppose, beta, if you are considering element from this side, beta. So again, you can tell beta same thing. Again, beta, I can tell same thing here. What beta? This is electric field direction, beta, in this direction. So this is what? Again, beta, I can see theta. So this is theta, beta. So you can see d cos theta, d is sin theta. Due to symmetry, students, you can say d is sin theta cancelling each other. Due to symmetry, beta, I can say d is sin theta cancelling, my dear, each other. Right? So, students, here I'm going to write your direct result of this question because this in the beta derivation is not required, but I give the approach remains same, but in the previous questions, but just calculate, my dear, you will get here electric field net beta. This is beta k lambda by r, k lambda beta r. This is into beta. This is what you can say, this is 2l upon beta ji. This is a root of 4 R square plus L square. Yes, beta. Just keep in mind here, one time beta, I can say, not one time, more than one time, beta. JE students, I can say, beta, for this result, one time JES, no, JES beta multiple time, more than one time, beta. Same result, beta, you can use beta in electrostatics as well. For entire derivations, if you want, then you have to just comment in comment box. If I'll get your comment, I'll revert you. I'll make video if you wanted entire derivations of this. Yes, bacha ji. Now, bacha, here you can write here. Lambda is what? Charge per unit length, beta. Lambda you can replace, my dear, charge per unit length, bacha ji. Okay. Now, beta, next questions here. Next, beta, derivations. I'll not derive this. I'll give the formula, my dear. So, this is what, beta? You can take electric field due to students. This is, beta ji, electric field due to, beta, uniformly, beta, you can say what? Long threads. This is what beta long thread, yeah. Right. So beta, long thread beta, or you can say beta, you can also write where. This is what beta is the very long. Or beta, you can say what, my dear? Infinite wire. Yes, beta. This is what you can say infinite wire. So, beta, I can say before beta write formula of this, I wanted to beta teach something here. So just listen first, beta, this one. Beta, this is electric field due to student. I can say electric field due to finite, finite, bacha, length of wire. Finite length of wire, beta. Or you can say uniformly charged finite length of wire. So, beta, you can think beta like that. Yes, it's beta highly required. You can take beta. This is what you have a charge wire. There is a condition beta. You can take like this. Student, this is what, my dear? You can take beta. This is what theta 1. Students, you can take, my dear. This is what theta 2. But it's literally a very, very useful, my dear. Students, literally this formula beta very, very useful, my dear. Right? They mention beta. This is what lambda. You can take beta lambda coulomb per meter. But I know beta for this derivation, yeah. You will get beta. This is what you will get beta. This is E perpendicular. What's the formula, students? K lambda by D. This is beta the sine theta 1 plus student sine method theta 2. Beta, this is what, my dear? E perpendicular. Sine theta 1 plus what you can say, beta? Sine theta 2. Yes, beta. There is one more formula, beta. This is what, my dear? A parallel. K lambda by D students cos theta 2 minus cos theta 1. What, my dear? Cos theta 2 minus. Yes, Anurag Dubey. 2k lambda by D. Uh, uh, Infinite large. Correct. Anurag beta. Correct, Anurag beta. Okay. So we know beta, this is a formula here, which I wrote over here. The same thing beta, I'll apply here with Anurag. Yes, Anurag beta. Here beta. Listen beta. So beta, this is what infinite beta body. So for infinite beta, what you can say is that this is what D. This is what D. So you can tell beta, what is the maximum possibility of theta 1 and theta 2? You can see beta, theta 1 and theta 2 maximum you can write beta. This is what beta is 90 degree. This is what Vitaji 90 degree bacha. So here students you can write E perpendicular. This is K lambda by D sine 90 Vitaji. Sine 90 plus Vitaji sine 90 degree. So E perpendicular you can write my dear 2K lambda by D. Very good beta ji. Now beta, what about E parallel my dear? E parallel is what? Zero. Why zero? Because beta, what is E parallel formula here? Just now I said K lambda by D. This is cos theta 2 minus cos theta 1. I hope all of you remember, student, cos of 90 degree, which is equals to 0. Due to this beta, what you can see, E parallel, in E parallel, which is electric field is what which I can say 0 for infinite wire. But I have a look which I can say next, my dear. Uh, this is what which is you can say electric field. Students, you can say electric field due to beta semi-infinite wire. What, my dear? Semi Semi-infinite wire. Right, bacha? Okay, my dear. So beta for this condition. Let's have a look at little point beta I'll discuss. Yes, beta. One end beta, you can say this is what beta here you are fixed. We wish to find what electric light point D bacha. You know beta, one end beta, you can say infinite. K lambda by D. No beta Anurag. Anurag, no beta. Answer is not correct beta Anurag. Just think once again. Beta for this condition. Theta 1 you can write my dear. This is what 90 degree. Theta 2 students you can see this is 0 degree. Right my dear. So now here I'm going to find this is what E parallel beta G. But here beta I can say first I'll find E perpendicular beta. First beta I'll find here E perpendicular. Formula beta remains same. This is K lambda by D. This is what, my dear? Sine theta 1 plus sine theta 2. So, beta, you know your sine 0, 0, bacha. So, you will get beta E perpendicular, you will get bacha K lambda by G. Now, beta, this you can write here E parallel beta. This is K lambda by G. This is cos theta 2 minus cos theta 1. So this is what students? Yeah, you know, sir, cos theta 1 is what? 90 beta. This is what beta? 0. So you can write, my dear, this is K lambda by D. Beta, you know here, but here, bacha, you will get both of the things here. Beta, you can write, sir, here I have E perpendicular, which is nothing but K lambda by D. Here, students, you can write, my dear. Beta, you have also what here? Sir, this is what I had written. K lambda, beta, you wrote K lambda by D only, Anurag, beta. Beta, you wrote only K lambda by D, bacha. But here, beta, E pen, you can beta categorize Anurag, beta, my dear. I'm very happy to see, beta. I'm going to almost beta 1 o'clock. You joined live session at Physics Fund, beta. You most welcome. All the very best for your coming time. Beta, you can write beta in chat box. Bacha ji, this is E perpendicular and this is what E parallel. So beta, just simple bacha. No beta, both electric field beta. I said beta in yesterday class. Electric field beta, what I can say belongs to quantity vector bacha ji. So this is you can say bacha K lambda by D. So now beta, just you can add beta this two electric field using what formula of a square plus b square plus 2ab, my dear, cos theta. Now, Anurag Deve, correct answer. Now, Anurag beta, your answer is correct, beta ji. So, what's answer, beta? This is neat electric field, beta. Root 2 K lambda by D. And angle, beta, I can take from here, beta. For neat is what, beta? Angle making electric field net with vertical component is what? 45 degree, my dear. Okay, my dear. Now, bacha, this is all about, I can say basics point here. After this beta, I can see I can start here numerical. Students, I can start here numerical. It's a highly required bacha. It's a highly required bacha. Okay, come beta. Come on, Rag. Okay. So bacha ji, you can say bacha, little bit. I'm just asking beta few questions. It's literally beta, basic questions only beta. Okay. So what's the question beta ji? Listen beta ji, carefully. Beta, you can take for consideration. Beta, as I said, if we have a this is what positive charge, beta, you can say lambda coulomb per meter, right, beta? Lambda coulomb per meter. Okay. Beta, this is electric field, beta, perpendicular here. This is what made here electric field, beta. This is what direction of electric field perpendicular. Beta, let us suppose this is means already not suppose already be proved. We know E parallel beta. But now, beta, I'm going to change beta lambda of what beta. You can say this is what which is the minus lambda coulomb per meter. Now, beta, you have to comment over here. Direction of E perpendicular at point P and direction of E parallel at point P. Direction beta E perpendicular at point P bacha and E parallel at point P bacha. You can tell here. This is nothing but it's a point P. It's a point P. Answer Anubhav beta, not Anubhav, Anurag Dubey. Yes, Anurag Dubey beta. Anurag Dubey, answer me this question, beta. I asked, what is the beta direction of E perpendicular and what is the directions of E parallel? If your, I can say, finite length of wire is charged with what? Minus lambda coulomb per meter. Minus lambda coulomb per meter, बच्चा जी. Yes, beta. Answer me. Okay. Uh, Anurag Dubey, maybe I didn't get the answer from your side, my dear. Okay, now beta, I'm going to explaining here these questions. Bacha ji, no, just beta reverse you can do bacha. You can tell my dear, sir, this is what direction of beta is EPA. Okay, towards the wire by 45 degree. Beta towards the wire by 45 degree, bacha, which direction? E perpendicular or E parallel? Anurag Dubey beta. Okay, so this is what beta you can see E perpendicular, my dear. This is what, my dear, E perpendicular. Now, students, you can say this is what, my dear. This is just beta replace here this thing. This is students beta G E parallel. Beta G, this is what net electric field. Net electric field, beta. That is a beta. You can think beta like that. Okay, fine, bacha buddy. So I think beta, you got Anurag Devi beta everything basic point bacha. Now beta, have a look at numerical you can do bacha. You can do bacha. Numerical my dear. Okay. Beta find in this question beta find electric field uh students find students electric field due to find electric field due to this frame. Find electric frequent due to this frame beta. I'm just making beta diagram here. Okay. Yes, beta. You can think beta carefully. Yes, yes, my dear. So this is a condition, bacha ji. Right. You can take bacha. What's the charge over there, bacha? Here, beta, charge lambda coulomb per meter. Beta, here I'm considering bacha charge 4 lambda coulomb per meter. You can take beta 1 4 bacha. You can take bacha ji. This bacha 2 lambda coulomb per meter. And this is last year. I can say bacha this is minus 3 lambda minus 3 lambda coulomb per meter. Assis, which class are you studying? Yes, beta. Physics only beta. Physics beta for 12th grade beta. 12th grade beta, I can see J means if you are beta, you will go to right. Beta J means advanced systems 2 beta. For J means an advanced beta which held according to curriculum of NTA. So beta, this is class beta. Deserving for J means an advanced student. J and means J and beta what? Advanced student beta. Okay, come bacha party to the point here. How can we do? Easy bacha, you can do literally. It's very easy bacha party. But I'll go slowly here. It's a bit of long questions beta. Right? So student, I'll go here slowly. Bacha, one point all of you pretend sure. This is what beta center point. This is what my dear center point. Okay. Now students, you can see here. This angle must should be what beta? 45. This angle also which has what you can say 45. So beta I'll take one beta and this I'll apply beta in all. Right, my dear? Okay, so come to the point. Beta this is lambda coulomb per meter. So student, this is what I can say solution of this question in step one beta. I'll explain here one, two, three, four, all beta in different steps so that you can understand better because you are paying time in night 1 o'clock beta. It's literally required to explain slowly so that you can understand my dear. Beta, I'll take beta. Let us suppose I'm calling beta. Beta for my own convenience here, I'm calling this is buyer one. Student, I'm calling this is buyer two, my dear. This is I'm calling beta wire three. This is I'm calling Bachaji by 4. That is, this is my own consideration, my dear. Okay, fine, beta. So here, students, I'll take one by one, beta, all the wire. Beta, first I'm considering beta wire number one. Students, here I'm considering beta wire number one. So what's the charge over there? This is lambda coulomb per meter. Students, this angle you can write easily, beta. This is what, my dear, 45 degree. This is also, my dear, 45 degree. This is also, my dear, 45 degree. You can add beta once. This is beta 45 degree. This is what? Beta, you can say 45 degree. Beta, if this angle is 45, bacha, so first you can say, bacha, theta 1 is equals to theta 2, which is equals to beta 45 degree. Right. So beta here, yeah, again I'll find beta E perpendicular. Beta this is beta direction. Beta what you can say E perpendicular, bacha. This is what direction, bacha. You can say E perpendicular. This is beta. You can say direction, bacha ji E parallel. E parallel beta. Okay. So E beta first I wanted to find bacha. Okay. Anurag Dubey. Uh, okay. Okay, wait, beta. Just solve slowly, beta. Anurag, give me beta time, beta. Okay, so beta E perpendicular here. Beta, what I can write with my party? This is beta G root 2 K lambda by D. Beta, what is the R? It's a square frame, no, bacha. So you can see, bacha. You can take beta sides of the square frame. This is A. This is A, bacha. So you can write, bacha. This is what? Simply, bacha, party A only. I can bacha party. I wrote beta everything. Cos 45 beta 1 na beta. This is what 2 beta goes up here. But do rationalize in bacha party. For this var beta, we have what? Only electric field in x direction. Only what beta in x direction. Anurag bacha. Okay, wait beta. I'll verify your answer. Now bacha ji, this is what I can say part 2 bacha. Or you can say wire number 2. Yes beta. This is wire number 2 beta. In step 2. What's wire number 2 bacha? This is beta bottom wire. Beta, what is the charge bacha party over here? This is 4 lambda per coulomb. It's positive itself bacha. 4 lambda per coulomb bacha. So again, you can say bacha this thing here. Make diagram beta. Once beta, this is what 4 lambda per coulomb. Now beta, I can say this is what E perpendicular. What beta, I can say this is what E perpendicular. Beta, no need to for E parallel here. That is remains 0 only bacha here also. So beta, you can say theta 1. Student, this is beta. You can write my dear theta 1 and this is beta g theta 2. So you can say theta 1 is equals to theta 2, which is nothing but it's a 45 degree. Theta 1 is equals to theta 2, it's nothing but beta. What you can say 45 degree. Students, here I'll write here. Beta, this is E perpendicular. Formula beta K lambda by D, which is this is sine theta 1 plus straight sine theta 2. Beta, both are beta, what you can say 45 degree are. Uh, this is okay, Anurag Vacha. Okay, you change your answer, beta ji. Then wait, Anurag, my dear. Wait, Anurag, my dear. This is K lambda beta and D beta what? D remains A bacha here. D remains here, here bacha. This is beta what you can say? Uh, 2 by beta ji root 2. Beta multiply divide bacha. So you will get root 2 K lambda by A bacha. Positive beta you can say by cap. Beta positive bacha what you can say bacha by cap bacha party. Right now. But lambda beta how much here? Mention bacha. This is 4 bacha. So beta multiply by 4 here bacha. Right. So finally, you can write bacha, E perpendicular is equals to beta 4 root 2 K lambda by A beta G J cap. Yes, beta. This is the correct part. Now, beta, we have another here. I can see this is what. Beta remains beta positive here. This is rod number 3 beta. This is beta remains positive beta. This is 2 lambda, my dear. Right. So beta G, this is I'll take beta in step 3 beta G. Right. So in step 3 beta again here I have this is the bar. Now beta G. Okay. So students, you can say it's positive only beta, so no need to worry. Again beta, you can say one component is what beta remains 0 if parallel beta. If perpendicular beta will get in these directions. This is what my dear 2 lambda 2 lambda what you can say beta coulomb per meter. Coulomb per meter. Beta, you can say this angle and this angle. Beta, both are 45 degree. Beta, what you can say beta 45 degree. So beta, this direction will get beta party E perpendicular. What my dear? E perpendicular. This is K lambda by D. D beta remains A only beta. No. It's wrong, bacha. You can't say. Beta, maybe. Did I say no? This is correct, Niyar only. This is correct, bacha. Party 402. Huh. Correct only, bacha. Okay. Now, bacha ji. Beta, we'll go through this here. So, beta, what will get bacha for this one is bacha? This is what? K lambda by what, beta? This is what? D. Then, bacha, this is beta a d is what bacha? D beta will get this one here. So a by 2 only bacha. So beta d is equals to, you can take beta a by 2 cos 45 beta. Just this is here sin 45. So this is what? 2 by root 2, my dear. Oh, Shamrit Gupta, hello beta, how are you? Yes, beta ji. So beta, for this condition here, you can write, my dear. Uh, this is what beta? Just everywhere, keep in mind, bacha, e perpendicular bacha, right? D beta everywhere a by 2 bacha only. So this is beta 2 goes up here, 2 to the 4, right beta? So you can see finally this is 2 root 2 k lambda by, this is what? A beta minus I ka beta. No, everything I'm slowly just beta solving it slowly beta so that you can understand, my dear. Okay, the last step beta. This is what I can say step 4 for this questions. Beta, this is what I can say beta. We have last one. Beta, this is minus 3 lambda bacha. Sir, please read something to me. Yes, beta. I can say beta step 4 bacha. So this is, my dear. What beta is it? Minus 3 lambda. I'll see beta once beta again here. Yes, correct. Minus 3 lambda. Now, students, again you can say, sir, E parallel remains 0. Beta G, E parallel remains 0. Yes, beta G. So this is what you will get beta only E perpendicular. And D is what, beta G? This D you can write, my dear, as usual A by 2. So beta, this is E perpendicular beta. In downward beta, I can say minus J cap. Students, E perpendicular beta. This is what you can say, bachcha ji. This is same result, na yaar, but lambda will be changed only beta. Lambda will be changed only. Oh, I see it wrong beta. Samriddhi, I can say Anurag beta. It's wrong beta. It's negative, na yaar. Just tell me beta Anurag beta. Like, it's wrong Anurag bachcha. It's negative bachcha. So beta go inside here. I didn't care beta this one. Beta, this one will go inside Anurag bacha. Inside beta E perpendicular here, which is positive y-axis bacha. What beta I can say? This is 3k lambda by beta A by 2 into beta G 2 by root 2. Beta what you can say 2 by root 2 here. T is equals to A by 2 bacha. Just keep in your mind here. Okay. So beta, this is beta just multiply divided by root 2 beta. Then you can say 1 root 2 finish bacha. So E perpendicular, you can beta finally you got 3k lambda by A. This is what, my dear? 2 root 2 plus secant. Simple, yeah. We calculated all data. Now, beta, we wish to find net electric field, my dear. Beta, we wish to find beta net electric field, my dear. Okay. In fact, beta, I have taken here somewhere dissociate A by 2. So beta, you can add simply beta party. For beta, net electric field. बच्चा जी net electric field. बच्चा here student, uh, here student again I'm considering here D is beta what? A by 2 beta. So that I can take beta entire terms is common. So this is what, my dear? K lambda by G. Beta, this is what we got here. First case beta. This is what? Root 2 beta. Beta, what you can say? This is root 2 beta ji I cap. Then beta ji, this is here plus beta. Already I solved the property here. Plus, my dear, 4 root 2 beta ji j cap. Then beta, this one here. Beta, what you can say? Minus beta. This is what? 2 root 2. Student, already I solved everything. 2 root 2 beta what? I can बच्चा last में बच्चा last beta what you can see 3 root 2 plus beta only 3 root 2 beta the j cap. Right. Simply बच्चा you can say 4 root 2 beta and 3 root 2. Beta what you can say beta just simplify बच्चा further. Simplify beta जी further. Electric field बच्चा जी net यार k lambda by d. Beta this is terms here just you can just little simplify बच्चा. You can take here root 2 I beta is common. You can write beta then what? 1 minus 2. Beta. Then beta what you can say 4 plus 3 here. Plus 7 root 2 beta j cap. Beta this is answer of this question here. How big question? What's your answer beta Anurag? You wrote 10k lambda by L. No Anurag beta. I'm getting different answer beta. Maybe what I have taken maybe net electric field. Sir, if L is equals to A by 2, then it will be 20k lambda by 2. Okay. So, beta, you calculated net electric field because I wrote it in form of vector beta. And here, beta, I have taken D only beta. D I didn't replace by A by 2. D beta, I have taken D beta itself. I didn't replace D beta A by 2. Beta, already I wrote my D over here. Yes, beta ji. I hope you got it, my dear. Okay. Yes, sir. Oh, very good. Very good, my dear. Anurag, I'm very happy to see, Bacha. It's time with a 117. Still, you are very active. I can see me and you with learning only two people here. Hats off. Very good, Anurag, Bacha. Okay, then I'll do beta only theory beta finish Anurag. Beta only numerical I'll throw Bacha. I'll throw beta Anurag only numerical Bacha ji. Have a look beta. Next question here. Have a look beta the next question. Find beta a students find electric field. Find student. This is electric field with a figure shown. Yes, beta. Find electric field with a what figure shown. No, but what's the question here? It's not tough, but it's a little yeah, thinkful question, bacha. Beta, basically we have a infinite wire. What bacha? Students, we have a infinite wire, right, beta? Okay, so beta, this let us suppose I bandage, right, beta, infinite wire. So beta, you can say this is the infinite wire, but beta, this is what in the shape of L, beta. You can take consideration like this. Yes, beta, ji. Infinite wire, beta, but it's what bending, beta, in terms of you can say what in the shape of L, beta. Okay, you have to find. You have to find net electric field at point O. Student, you have to find net electric field at point O. This is O beta. You have to find what's the net electric field at point O beta. Yes beta. You can try beta. This dimension also mentioned student. Yes beta. You can take care consideration. You know Anurag beta. These all are my class questions here. Anurag beta. You know why I'm taking live class in the night here because daytime beta literally I totally occupied here, but I'm looking help for each and every student span India. That's why student I decided here to come in the live and teach each and everyone. Yes, beta. This is A bacha. Mention the questions here. But you have to find electric field due to these. You can say beta lambda. You can take bacha. Students, you can take lambda coulomb per meter beta. Lambda coulomb per meter bacha. Okay, very good. No, no, I'm very happy to see beta. your enthusiasm and dedication, Anurag. Now we are time. It's very good, bacha. Definitely, beta, you are doing effort. Beta, your hard work will cry one day, beta, in the form of success. Right, beta? You know what you are doing here? Everything will get. Everything will get here. According to beta time. Yes, beta. Now, bacha, fine, beta. Electric field at point O. Fine, bacha ji. Electric field at point O. Hmm. Anurag, are you calculating, my dear? Are you calculating, my dear? Okay, fine. Okay, root 2k lambda by uh, a. Okay, Anurag, I'll see, bacha. I'll see, bacha. I can solve it. Then I can tell you, bacha ji. Yes, this will take have a look of the solution. Yes, beta, have a look of the solution here. Right. Okay. Beta, yeah, for my own convenience, beta, I'm considering beta few assumption here. Let us suppose beta I'm considering beta this is wire one beta this beta wire students I'm considering beta z two. Yes, beta z. Correct. Sir, no, sir. Let me calculate once again. Okay. Yes, beta. Beta, calculate beta once again. Beta, I'm also calculating, bacha. Then, beta, you can meet your answer with me. Now, bacha, beta, I'll take care first wire. Beta, I'll take care first. So, instead, one, bacha. This is for wire, for wire, one, bacha. Ji. Yes, beta. This is A beta. So this is D beta. This will diagram beta. Diagram beta will help you. This is infinite Bachaji. This is basically you can say point O. This is point O. So this is beta known for us here. This is what known for us beta. This is beta how much? You can say A only. This is beta what you can say? A only bacha party. Okay. So beta for this barrier, beta what you can write my dear? Beta, this is what? Beta, while one bacha. Yes, beta. This is beta is A perpendicular. And this is what, my dear? My dear, this is E parallel beta, right? Okay. Beta, what you can say? E perpendicular bacha and E what you can say? E beta is parallel. Okay. Now bacha ji, no, beta, what is theta 1 here? Beta, theta 2 beta remains 45 only bacha. So theta 1 beta you can write. This is what beta? Theta 1 beta what you can write beta? It's 90 degree only. What about theta 2 beta? 45 degree only beta. Theta 2 what beta is it? 45 degree only, right? So beta just calculate here. E perpendicular K lambda by beta. This is remains only beta. Okay, sine 91 here. Plus beta sine 45. 1 by root 2. E beta perpendicular. Beta for I calculated beta forward one beta. Now students I can say this is E parallel. What was it? K lambda by G. This is cos theta 2 minus cos theta 1. E parallel there. So theta 2 beta 45 here. Theta 1 beta 0 only. So what you can see is that this is what K lambda means root 2 K lambda by G. D beta everywhere A only, yeah. No need to worry. Okay. Now, students, I'll do here a discussion of what for buyer to beta. Okay, okay, Anurag. Okay, okay, Anurag beta. Okay, beta. Wait, beta. So now, students, I can say in step two. Anurag in step two, bacha. For I can say, yes, beta. For wire, beta. For buyer two only. So this is buyer two, beta. This part is what you can say infinite, bacha ji. So this is basically point A, O. So beta, you can see beta for this condition here. This is what? Tell bacha ji. This is what? You can say beta E perpendicular. This is students E perpendicular. And this is my dear. You can write E parallel. This is what my dear? E parallel. Okay. Okay, and beta. Beta again same thing here. What? You can write beta. This is theta 1 which is equals to my dear 90 degree. Theta 2 is what beta ji? 45 degree. Theta 2 is what beta? You can say basically 45 degree. Okay, beta, I'll calculate here. E perpendicular. This is beta ji K lambda by A beta. D itself A beta only. Sine 90 beta 1 plus 1 by root 2 beta. This is what you can say bacha ji I cap. E parallel beta z. What you can say my dear? Cos theta 2 minus theta 1 beta. Yes. Simple bacha. K lambda by A into root 2 beta z cap. Beta I'll make here in step 3. Students in step 3, I'll make beta one more diagram for final with party. So I can say, yes, this is what, where it gets, yes, beta. This is, I can say E perpendicular for wire 2 beta. How much here? This is K lambda by A 1 plus 1 by root 2 beta. For this wire beta, this is parallel. A beta is parallel here. How much? K lambda by A into beta root 2. This is finished beta g. Now we are for previous buyer. Yes beta. For previous buyer beta, I can say means buyer 1. Beta for buyer 1 beta g. This is what? Perpendicular here. This is what my dear? I can say perpendicular. So beta, what is a perpendicular beta button? Hmm. Yes beta. This is what my dear? K lambda upon A beta 1 plus 1 by root 2. 1 plus 1 by root 2 beta. Now beta, this is E parallel beta for this wire. E parallel beta for this wire. Beta, what about this one here? Okay, root 2 K lambda by A. Root 2 K lambda by A. Now beta, I can say simply here. Bacha ji, root 2 K, beta, what I root 2 here? This is beta theta 2. So this is 1 by root 2 linear. Yes. Now beta correct. Hmm. No. Beta here also here. E parallel 1 by root 2 only beta. 1 by root 2 beta. 1 by root 2. Yes beta. No. Now beta I can say everywhere beta. everywhere what's a party, you can say 1 by root 2. You can see beta carefully. K lambda by root 2 beta and K lambda by root 2 cancel. Beta here also here. K lambda by E into root 2 beta and K lambda by A root 2 beta cancel here. So what you will get beta? Finally beta you will get finally this is K lambda by A and beta in this direction also remains same bacha. K lambda by A. Beta both belongs to quantity vector student. So what's answer bacha party? You can see our electric field net at point O. It's nothing but root 2 K lambda by D. D is equals to AR. So student, this is answer of the question. Now I'll see your answer. Anurag. Oh, root 2 K lambda by. Oh, very good. I'm proud on you, Anurag beta. Literally, beta. I'm feeling proud on you, my dear. Yes, beta. Now, Anurag, beta, move on next question here. Yes, beta ji. So find electric field beta at center. Questions remain same, bacha. Students, find uh, find electric field. Find electric field beta. Find electric field at center beta. Find electric field at center. Uh, beta Z figure shown. It's a beta your homework beta. Or beta you can answer me beta within 25 seconds. Yes beta. What's the question bacha? Have a look once. Beta. This is again students I'm considering here. It's a square frame. Or you can see beta there are four wires. Beta now I'm going to beta connect. Yes beta ji. Uh, you can beta you can say Anurag beta ji you can contact beta right. Anurag beta if you want beta fast compliance of syllabus beta right. So my dear you can contact beta here right. This is beta contact of physics point. Beta landline number beta for call and beta WhatsApp number beta also applicable. Mail ID beta also applicable. If you want to beta, I can say syllabus compliance fastly beta for mains, advanced, or any particular chapter beta. So here is one also beta individual tuition available beta online mode. You can also beta, you can explore your career as students here for this one. Always ready to help you beta. I hope you have taken a screenshot of the I can say contact detail of this one beta. Okay beta. Now yeah, have a look next. Does you have a look next beta? Okay. So what beta? This is what beta. There are four conducting wire. Beta, Chirag beta. This is Anurag beta. This is your assignment beta home. Beta, you can take beta. This is बच्चा जी plus lambda coulomb per meter. Beta, this is again beta I can take plus lambda coulomb per meter. Here students, बच्चा जी, my dear, minus lambda coulomb per meter. Anurag, from where you are watching currently physics point video, from where you are lambda coulomb beta, right? UP, Jaunpur. Oh, most welcome, beta. Yes, beta. I can see. By the way, I got daily one boy, beta. Also regularly, beta. I can see joining the class. But by the way, that boy also demanded, beta. That boy, beta, actually going LN. Beta, I can say Lucknow, right? Literally, he's a bright student. He also that boy also expecting beta only for advanced questions, right? But my class, beta, my teaching methodology, beta, Anurag always there, zero to hero. always with beta, but anywhere, yeah. Here बच्चा also beta an institute as well बच्चा anywhere बच्चा same content you will get बच्चा either online mode beta or offline mode बच्चा but slowly yeah. Now beta in classroom बच्चा I have to usually fast बच्चा Anurag yes sir too fast बच्चा in the classroom बच्चा but yeah here in live Anurag so I'm taking yeah class little slow you can take beta Anurag बच्चा this is a what बच्चा is a is beta you can take this is what beta sides of the square. Yes, beta. This is the questions. Students, you have to calculate my dear. Students, electric field at point O. Students, here you have to calculate say what electric field need due to all bar. But this is beta assignment for home Anurag. You can solve it, you can WhatsApp me beta or you can mail it. Already I gave it all information. Either beta, the solution of this question, beta, I'll give you beta very soon. Telegram channel of this point as well. For meanwhile, you can use beta WhatsApp or mail, beta. You can beta answer me this question, beta, by your by time, live session, beta, or name and your place also. Beta mentions beta in the solutions. Now, beta, buddy, move beta next question here. And Rag, should I do next question? Okay, you already answered this question. Okay, I don't know. Hmm. Anurag. Anurag. No, 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 no Anurag. Okay, now I'm solving. But I'm solving Anurag. But your answer is not correct. Do you want do again these questions? Student, do you want to do again this question, Anurag? Okay, I'm calculating bacha party. It's not a homework, right? Okay, again, yeah, I'll take beta for my own convenience, bacha. This is beta. I'm taking a wire one. This is wire two. This is wire three. Once again, yes. Let me see. Yes, yes, yes. Yes, beta. Yes, beta. Your answer is no. No. You did, beta. Maybe you didn't calculate it net. Check once, beta. Your calculation, my dear. Beta. This is wire third, beta, and this is what, my dear. I can say wire four. Yes, beta ji. So, beta, I can say, beta, for this condition here, beta, we'll go here slowly, slowly. Beta, let us suppose in solution, Anurag, I'm considering, my dear. I thought you are one time Anurag student also. I thought one time Anurag, I can say one kid, if previously I was somewhere, right? And coincidentally, bacha, that was also from UP Jaunpur only. Huh. I'm pretty sure that was from that. I can say UP. I'm pretty sure. Yes, 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 yes. Now, beta. So, beta, have a look here. I can say solution of these questions. Yes, beta ji. Uh, Now, students, I can say this is beta g by 1 year. Now, beta d is what? A by 2 beta, as usual here. Right. Beta in last, I'll replace beta. I'll take beta d everywhere. Beta in last, I'll replace beta by d. Now, beta, this is angle known for us. Beta, we solved that previously same questions. This is, my dear, 45 degree. This is also, my dear, 45 degree. This is charge beta lambda coulomb per meter. You can see easily, bacha. Sir, this is what? E perpendicular. Sir, we will get only E perpendicular. That is what? K lambda by D. D beta A by 2. Yes. You can write beta 2 K lambda by A. Beta for this one, beta, this is beta only. E parallel, you can see beta 0. Why beta? Because theta 1 is equals to theta 2. Theta 1 is equals to what beta? We can see theta 2 here. And here beta again you can say this is what 2 by root 2 multiply divided by beta root 2 beta multiplied. Now it's correct. Beta this I'm calculating, my dear. These two beta finish. So you can see beta e perpendicular beta. E perpendicular beta this is you can write beta what 2 root to k lambda by a. Correct beta party. Okay, beta a parallel 0 यार. Beta for this rod beta. Second beta. For rod number second बच्चा party. Beta just make diagram बच्चा. It's again beta positive only. So students, you can see beta for this answer. Same beta you will get. Same student. This is also beta 45. This is also 45 beta. Here beta again you will get same answer here. This is 2 root 2 k lambda by a. Beta for third beta. Interesting here. It's a negative beta party. So no need to worry here. For negative beta, I can say this is what? Beta from point 1 beta goes inside beta party, right? So beta, this is inside beta party. I can see beta for part 4 here. Beta, this one also beta party goes inside. Beta, same magnitude. Then beta, the what you can see, just beta for point 0 in beta final step, my dear. In beta, the final step, my dear. This is bacha. For this rod here, for this rod, beta, what you got? 2 root 2 k lambda by d, k lambda by a. Beta, this rod also going in same direction, bacha. Because this is the negative bacha party. This is negative beta. This one also beta in same direction here. So what we can see, this is add. So beta 2 to the 4 here. You can write, my dear, in horizontal directions 4 root 2 k lambda by a beta. What you can see, bacha? 4 root 2 bacha k lambda by a. 4 root 2 beta, what you can say, k lambda by a. Beta, same thing, bacha. Beta, this is beta. For positive, bacha, this is the directions of beta electric field. Beta, negative here, so again you can say, sir, both will again add normally. So, beta, this is beta. What you can write, my dear? This is Anurag, beta. You can say 4 root 2. This is k lambda upon a. 4 root 2 beta. What you can say, k lambda by a. Now, bacha, I can say, sir, this is what we wish to find here because no, electric field belongs to quantity vector here. Both are at 90 degree. So, beta, for get beta to write here an answer electric field net, students, you have to apply beta formula here a square plus b square plus 2ab cos theta cos 90 beta g 0. Simply, bacha, I can say 4 root 2 beta g k lambda by a beta g whole square plus beta 4 root 2 beta g k lambda by a beta g what this is remains beta g whole square. So students, what is the electric field need bacha? You can take it out here k lambda by a because it's under the square bacha. So you can take student. This is what remains out here. K lambda by A. Here bacha, beta square beta 4 root 2 beta 4 4 just 16 32 bacha. This is 32 beta. This is 32. So finally, what we can say 64. Okay. So finally, beta I can write 8 K lambda by A. This is electric field net. Okay. Hmm. Yes. Anurag beta. Correct. Correct beta. Anurag. Now beta your answer now correct beta. Yes, beta, Anurag, your answer beta remains correct, beta. Now, beta ji, have a look, beta, next questions. Yes, beta, have a look at next questions. So, beta, what's the next question, sir? If particle, it's a beta, I can say question, beta, from SSM here. Yes, do beta, Anurag. It's a good question, my dear. It's a good question, beta ji. If, uh, little beta, just note down here, I can say, beta, theory here. Statement of question is, if particle is a particle is slightly displaced. Students, if particle is slightly displaced, perpendicular to where? What, my dear? Perpendicular to where? Perpendicular to where? and released. No, but I'm just writing here, bacha, because this is a live session. In normal class, beta, I never ever. Uh, then, then find out time period of SHM. Then students find out, beta G, find out, my dear, time period of SHM. Find, beta G, time period of SHM. Yes, beta. Listen here carefully. But I'll also diagram that because, as I said here, I never follow through this right here CBSE statement like this. But I'll just go through beta what's a diagram at everybody. Hmm. Yes, beta. Anurag. Next beta. Beta, what's the question here? Students, you can take for consideration. Beta, this is what? Infinite charge wire, my dear. This is beta infinite charge wire. Yes, beta. Yes, beta ji. Okay. Now, students, you can take this is beta. This is uniformly charged here. Lambda coulomb per meter. What bacha? Lambda coulomb per meter. Okay. Anurag bacha, what's the questions I'm giving you? Beta, initially, beta particle is at a distance d. That is, you can say beta location of particle perpendicular distance which is placed at a distance d from uniformly charged infinite wire beta. This is G mentioned for us. Now beta you can take beta for this point, beta this point. Beta charge Q and mass initially here only. But everything beta just have a look beta. We have to find time period of a system. But we have to just displace this charge particle little beta in upward directions, or you can say perpendicular to rod. Then we have to find what time period of SHM. Beta time period of what beta you can say SHM. It's a good question beta. Anurag, do you want to try beta this question or I have to do beta? So let me try. Okay. Okay, beta. Do beta. I'm giving you beta. I'm giving you beta 65 seconds. Do beta Z. Then beta. I'll do. Then I'll do my dear. Now it's a live semester, but it's a normal class here. It's normal class, my dear. Yes, beta. It's a normal class here. Do beta. Okay. Yes. Hmm. Okay. You already answered it, yeah. 2 pi root of g upon g plus q e by m. Okay. Very good, Anurag bacha. Just give me beta. I'll do beta these questions. Then beta I'll take your answer correct or incorrect. Now bacha, have a look here. I can say beta solution of this question beta. Right in solution. Beta you can think beta like that. Before displacing the charge particle, beta you can take initial condition. Student, before displacing the, I can say, charge particle. Simple beta. What you can say? Sir, it's nothing but this is what QE is equals to beta mg. No beta mg beta. You can just make diagram beta FBD. FBD physics is a better language of FBD. mg bacha g, and this is what my dear? You can say QE. Beta, I can say without any disturbances, system is in equilibrium, so you can equate my dear. Just now, beta, we finished here. Electric field due to infinite charge wire. So you can write, my dear, for this condition here. Beta, this is what mg QE and E beta 2k lambda by d, which is nothing beta. You can say what mg. Which is beta what you can say mg only. Is the electric field. Sir, I have finished my lecture homework, so I have to go. But this is the last question, bacha. Just you can finish, bacha. Just beta, just bacha, you can just I'll tell you the answer, correct or incorrect, bacha. Then you can go, bacha. Beta, I'll beta continue classes around beta 2 o'clock, right? Hmm. Now, bacha, this is I can say it is step one for these questions, right? And bacha, this is step two, bacha. After displacing charge particle at a distance x, my dear, you can think like that. After displacing, after displacing a charge particle beta, right? Uh, you can say beta is at a distance x, at a distance x. Then, bacha, you can again here just think beta like this, my dear. This is beta basically infinite uniformly charged wire, right beta? So this is beta, as I said, there is little displacement. Initially beta what? At a distance d, at a distance d. Now beta from here onwards here, I'm just telling little displacement perpendicular to rod. This is nothing but it's x, my dear. It's a what, my dear? X only, right? So I'll write f net, which is expression. Because because for SM we have to prove f is equals to minus kx. So f net beta I can write. This is what, my dear? QE minus mg beta, right? So beta E, beta got change. F net beta, this is Q remains same beta. What is here? 2k lambda by d plus x minus beta g mg, minus beta what you can say mg. Now beta just do one thing here, because just now previously bacha party we already calculated bacha. What is the result here? We got q 2k lambda by d is equals to mg. Now beta I'll use beta this result here bacha party. So beta I'll take beta common d from here. So students, I can say for f net, uh, what bacha? 2k q lambda by d into beta 1 upon 1 plus x upon d. Beta what? You can see minus mg. Now you can student replace here. Student, you can replace my dear this expression is equals to what beta g? Mg. Now students, you can write here. This is f net. Mg beta, you can take it out. Then beta what you can say? 1 minus 1 minus x upon d. Upon which 1 plus x into which g only. Students, you can write for f net. Mg which just beta do your calculation बच्चा but LCM you can take beta. You can take my dear LCM only, right? Yes, beta g. So this is what beta I can say. Beta this comes in here. D minus d minus x upon beta g 1 plus x into d. D beta finish. Then beta you can say f net बच्चा beta. This is what mg बच्चा minus d beta 1 plus x beta what you can see 1 plus x बच्चा beta. You know बच्चा this is your x ignorable बच्चा x ignorable बच्चा because x is what you can take beta x is what much less than d बच्चा so you can ignore बच्चा beta. Beta this is student last I can say calculation for this question. Students finally you got f net is equals to what my dear minus mg beta what you can say बच्चा beta d plus x yeah beta how this is d plus x बच्चा beta right beta okay so you can say बच्चा beta for this condition yeah this is minus x beta जी so this is what minus mg into what dt cancel yeah so here x में beta this is what my dear x only minus mgx upon beta what you can say this is what बच्चा जी d plus x so x ignorable बच्चा party now beta only you can say what this is d plus x this is my dear d this is also d plus x बच्चा x beta negligible बच्चा so this is what you can say mg by d beta what you can say mg by D. So beta, finally, yeah, you can beta compare this result beta from what normal equation of SHM f is equals to beta minus kx k beta mc by d. I hope you remember my dear time period for SHM 2 pi under root m upon k. So finally you can add beta 2 pi root under beta. This is what my dear you can say k beta charge. So this is what m beta and there mg into d. Simple here. So m cancel beta. What we can write time period here? Beta final you can beta write you can support your answer beta party. Time period t is equals to this is 2 pi under root d by g. Oh, very good. Very good, Anurag beta. I'm very happy here. I'm very happy to see Vacha. Okay, so I can say no one is here, beta. Sir, please teach me something. Okay, still Samrit Gupta, you are here. What do you want to learn? Tell beta, Samrit. No one is here. I can talk you now. Tell me. Tell beta, Samrit. What you wanted from my side? In which class you are? First, you tell. Samrit Gupta, in which class you are? First, tell. Okay, class 10th. Very good. So maybe, beta, you will go to write 10th board na, beta, or just you entered in 10th class. I'm not able to solve the numerical of class 10th electricity. Okay, electricity numerical. Okay, fine. I can say electricity numerical na. Hmm. Okay. Beta and Samrit Gupta. For you, beta, I have a few offers. Beta Samrit, if you want to beta compliance of syllabus of your physics in 10th class, beta you can contact or beta give a number. Beta calling number also available. Beta WhatsApp also available with party. Mail also available. Write your concern, my dear. Right. And what you wanted, beta. Personal tuition, beta, available online classes, everything, beta. What you wanted, I'll help you. Students, I'll help you, beta. I hope you have taken a screenshot. Yes, beta. I'll help you, beta. Sandeep Gupta. Yes, beta. I'll help you, my dear. Okay. So, students, I can see this is all about beta. I can see today class. Now, students, I'm going to stop beta live classes. God bless you all. Till now, you are with me in live session at Physics Point. Forever help. I'm always eager to help each and all candidates. Okay, Bacha. Beta, basics. Beta, just we'll go through beta entire. Just beta, if you beta, just make beta for short notes of electricity student, right? And beta, just do beta last 5 to 7 year PYQs. Yes, my dear. Beta, just do beta last 5 to 7 year PYQs. And beta, PYQs will give you idea, my dear. Students, PYQs will give you idea, beta, which topic you have to pay more attention. Which topic has a more weightage, right, my dear? So you have to prepare yourself, beta, in this fashion. Definitely, student, you will get benefit. Still, let us suppose if you are not getting any improvement in the study in electricity, so beta, either you can join personal tuition or beta, you can just follow me regularly. If I'll get free beta from, I can say normal timetable at physics point, then beta, I'll arrange for you one live class. Right, bacha? Beta, just keep following, bacha. If I'll get free, bacha, definitely I'll help you, bacha. I'm Samrid, because physics point here stand to help pan India entire student, my dear. I hope you got it. Samrid, can I stop live class if your query is finished? I studied Alak sir, but I'm not able to solve miracle. No, Alak sir from where, beta? Oh, now, beta, Samrid, beta, this is live session. Can you, beta, talk me on WhatsApp, please? Samrid, beta, please. Beta, in live session, bacha, I can't speak more, bacha. Yes, beta. Right, bacha. So, beta, just, beta, already I gave beta contact number of physics one website party. Beta, you have this contact there only, beta. Okay. Samrid, should I stop live session? Thank you. Okay. God bless you, my dear. All the very best. All the very best, my dear.